So this is another style of problem which shows you in words a bunch of transformations and asks you to write that as an equation, either in function notation or in regular equation form. So I have two examples. They should cover just about everything that you're looking at. Let's just get started with this top one. So remember, when you write equations, you want to make sure you go in order. And these transformations are not in order. So first, I'm going to look for reflections, shifts. There's another, no, not shifts. Shifts come at the end. Reflections, stretches, there's another reflection. We're going to deal with these first. And then we'll talk about the shifts after we're done talking about the reflections. So I'm going to write over here. I don't have enough room in this box over here. So I'm going to start out with my equation, f of x. And I'm going to say, okay, I've got a vertical reflection. That's a negative. And what else is going on? Oh, it's a vertical stretch by a factor of 2. Well, that's going to be a negative 2 now. So negative 2 times f of x. And there's a horizontal reflection also. So what I'm going to do with a horizontal reflection is get rid of the x in the parentheses and replace it with a negative x. And if you're wondering why I put that negative sign outside of parentheses, that's to set myself up for the shifts that are coming up next. Now, let's just change colors. Shifts. We'll do the vertical by 3. That's an easy one. So that's just going to be a minus 3, right? But when we get to the horizontal shift, right by 1, here's what we have to do. We have to, let's keep the color scheme going, negative. We have to put that horizontal shift inside this parentheses. Okay, inside that innermost parentheses. And a shift right by 1 means x minus 1. So here's my equation. Kind of messy, but there it is. Negative 2 times f times negative x minus 1 minus 3. Okay, and now when you turn that into equation form, what we're doing is replacing the f with the actual equation. So think to yourself, f of x equals absolute value of x. Well, that means f of this ugly thing equals absolute value of that ugly thing. Oops, except that's not a parentheses on the outside. That's the rest of the absolute value symbol. So my equation looks like this. Negative 2 times the absolute value of negative x minus 1, absolute value sign, minus 3. Okay, that is your final form equation. This was the final form function notation, and that's how you do this sort of problem. Now, if you want, you could have written this thing right here as negative x plus 1, right? It's the same thing, but I just like to keep parentheses on there to keep it clear what's going on in terms of reflections and shifts. So with this one, we'll go through this a little quicker. I'm going to talk about compressions and reflections first. So I have a compression of 3/4 times f. There's no vertical reflection. So we move on to the inner parentheses where we see there is a horizontal reflection. Okay, and then we move on to the shifts. Just use the same colors like before. Vertical shift down by 3. Wasn't that the last one? Yeah, it was also down by 3. Okay. And now we have a horizontal shift by 4 to the left. So that's going to be this. It's going to be 3/4 f negative something. Then we have that minus 3 vertical shift down. And then we have this, what is this? Left by 4. Remember, left is plus 4. But because we've factored out that negative sign, it's easy for me to put x plus 4 right inside the parentheses there. I'm replacing x, and I'm turning it into x plus 4. Okay, so now if you want to write a final equation for this, what that's going to look like is the following. 3/4. Now what's f of x? That's x squared. So it's 3/4 this thing squared, where the thing is negative x plus 4. Right? It's the argument of the function. And then we have minus 3.